All right, today we're going to talk about section 1.4, perimeter and area in the coordinate plane. So first we'll talk about some polygons. So polygon is another word for shape, but not any shape. So all of these are polygons because they don't have any curves, right? This is not a polygon because it has curves. They're complete, so this one's incomplete. All of these are complete, they connect. And these are not polygons because they're three-dimensional shapes, right? It's a two-dimensional shape. And it will never have any lines inside of it. We could draw lines inside, but the polygon itself would not have any lines. So it is a 2D shape with straight sides and is closed. Right? Polygons have vertices. So vertices are the points, right? So A, B, C, D, and E are all points or vertices. Sides, which are segments. So side BC, side CD, side DE. And we would name a polygon by listing the vertices in consecutive order. It doesn't matter which one we start at as long as we don't jump around. So this one they called polygon A, B, C, D, E. I could have said polygon C, B, A, E, D as long as I'm going in an order without jumping around. So we have some perimeter and area formulas for a triangle, a square, and a rectangle. So for a triangle, if I look at the three sides of the triangle, perimeter is when I add them up. And the area is 1/2 base times height. Some of you may have learned it as base times, oh, that's not an inch, base times height over 2, which is fine. I can't write an inch apparently. Base times height over 2, but that's also 1/2 times base times height. The height is always perpendicular, always makes a right angle with the base. Right? So the base here is the bottom, the height is the line from the top perpendicular to it. A square, because all the sides are the same, they could say they're all S, right? If we call S for the side. So the perimeter, instead of saying S plus S plus S plus S, we could say 4S. And then instead of saying length times width like we do for a rectangle, S times S is S squared. And then a rectangle uses length and width. So there are 2 lengths and 2 widths. So adding L plus W plus L plus W actually gives us 2L plus 2W. And the area is length times width. So here's our first problem. We want to find the perimeter of triangle ABC, giving us vertices of A was at -2, 3, B was at 3, -3, and C was at -2, -3. So I can actually count the horizontal and vertical boxes. So we have 1, 2, 3, 4, 5, 6 on this side. And then if I count across the bottom, I have 1, 2, 3, 4, 5. But I can't count the boxes for AB. So I can either choose to do the distance formula, or because I already have a right triangle drawn, I could use the Pythagorean theorem. It's totally up to you which way you choose to do this. So let's say I did the Pythagorean theorem. So we're looking for 6 squared plus 5 squared equals C squared. So 36 plus 25 is C squared. So that's 61 is C squared. And I would take the square root of both sides because I really want this as a decimal. So we would get about 7.8. We round it to the 10. So now my perimeter is 6 plus 5 plus 7.8. So my perimeter will be 18.8. And they didn't tell us how much these boxes were, so we'll just say units. All right, and that's the perimeter of our triangle. This next one, we're looking for the perimeter of this parallelogram. So we can count the boxes that are horizontally. So 1, 2, 3, 4, 5. It's going to be the same over here. But now we have some diagonal boxes. So again, you could choose to draw it so it made a right triangle and use Pythagorean theorem. Or let's say this time we use the distance formula. So that was 4, 1. That was 2, -2. Get some more practice of the distance formula in here. So that's going to be x2 minus x1, so 4 minus 2 squared plus y2 minus y1. 1 minus -2 turns into 1 plus 2. So now we're going to have 2 squared and 3 squared. 4 plus 9, which is the square root of 13, which is about 3.6. So now I could put 3.6 on my picture here. So I know we didn't talk about area or perimeter of other shapes. Perimeters always add the sides. So even though we didn't have the parallelogram shape here, we can still just add up the sides to find its perimeter. So it's going to be the same as the rectangle was because I have 2 lengths and 2 widths here. So my perimeter would be 2 times the length of 5 plus 2 times the length of 3.6. So we have 10 plus 7.2, and we get a perimeter of 17.2, and again, we'll just say units. All right, you're going to check try the next one. Pause it, and then you can check your answer when you're ready. All right, let's check our answer here. I had sides, legs of 7 and 5, and I did the Pythagorean theorem to find my hypotenuse was 8.6. So the perimeter was 7 plus 5 plus 8.6, or 20.6 units. In the next example, we want to find the area of triangle DEF. So area, we know, is 1/2 base times height. So the base here, I can count. We have 1, 2, 3, 4, 5, 6, 7, 8. And now my height, I'm going to have to make an imaginary line inside that goes straight down, right angle, and that is 1, 2, 3, 4, 5, 6 units there. So now I have my base and my height. So 1/2 times 8 times 6, so 48 times 1/2 is 24. And area always gets square units. So I don't know what units they use, so we'll just say square units. Right. You could try the next one, pause it, and then when you're ready, play to see the answer. All right, so we ended up with a square that had sides of 3, so we could either look at it as length times width or sides squared. So either way, we get 9 square units for our area. So we have 2 more problems to do. So this is giving us blueprints of a shed in our backyard. The diagram shows the 4 vertices of the shed. Each unit in the coordinate plane represents 1 foot. Let's find the area of the floor of the shed. So just like the last problem, we can count our horizontal and vertical line. So this we have 1, 2, 3, 4, 5, 6 units this way. And then 1, 2, 3, 4, 5 units this way. So this is a rectangle. We can find the area by doing length times width. So 6 times 5, doesn't matter which you call which. And we get 30, and because this told us each one was a foot, 30 square feet. All right, you try this one. You can pause it when you're ready to check your, play when you're ready to check your answer. All right, so we have units of 4 and 5 for our length and width. So that's 4 times 5, or 20 feet squared. So that really ends our lesson. If you'd like to stick around to see the challenge problem, you can continue watching. Otherwise, that is it for section 1.4. So our challenge problem is asking to find the area of the triangle created by intersecting these lines below. So each one is written in what we call slope-intercept form. The number at the end is the y-intercept, so negative 2x plus 5 would be a 5 y-intercept. And then the number in front of the x's are slope. So negative 2 is really negative 2 over 1, which means down 2 for negative 2 to the right 1. And we would keep doing that and keep making our line by going down 2 to the right 1. But we could also go up 2 and to the left 1. So we would draw our line that way. And then I would connect them, right? It's going to be hard for me to draw a straight line right now, so I won't do that. This is x plus 5, so again, starts at positive 5, and the number in front of x is 1, which is 1 over 1. So I would have my line that looks like this, and I would keep going, and I'd keep going, and I'd keep going all the way. This last one, y equals negative 3, is a constant. There's no slope. It just goes through negative 3 and doesn't go up or down at all. It just goes across like this. So I'm going to look at our picture with those lines drawn for us now. So what this means is I know I have 1 point of the triangle there, 1 point of the triangle there, and 1 there. So I can count my boxes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I can make my height here as well and count 1, 2, 3, 4, 5, 6, 7, 8. And now I have a base of 12 and a height of 8. So I can do 1/2 base times height. And I get a total of 48 square units. All right, so if you stuck around, now that is the end of section 1.5.